Hello everyone. So in this video, we'll solve this problem based on the concepts of polynomial functions. So in this problem, we have to identify which of these functions is a polynomial function, and then for the polynomial functions, we have to state their degree and leading coefficient. So let's start with part A. A polynomial function is a function in which the variable in the equation have whole number exponents only. So all the exponents are like positive whole numbers. So in this equation, the first term is a variable term and the exponent on the variable is 4, which is a whole number. In the second term, there is a variable and the exponent on that variable is the invisible 1, which is a whole number, and there is no other variable term. So that's why this function is a polynomial function. And now we can state its degree and leading coefficient. So degree is basically the highest exponent on the variable, and that's in this term here. So the highest exponent on the variable is 4, so the degree is equal to 4. And the leading coefficient is the coefficient of the term on which the variable has the highest power or the exponent, and that's this term. So the leading coefficient here is positive 3. Now we have to keep in mind the degree of a polynomial function can be easily identified from its standard form. But if the polynomial function is not in standard form, then we have to either change it to standard form, or we should be able to visualize it to identify the highest power on the variable when we distribute the terms in the polynomial function. So now let's analyze part B. In part B, the equation is given in factored form. Now this is a simple polynomial, so we can quickly convert it into its standard form. So we can distribute the x into the parentheses. So we do x times 4, which is 4x, and then x times x, so we get x squared, so we get 4x minus x squared. So now this is a polynomial function because the exponents on the variables are whole numbers. So this is a polynomial. And now we can identify the degree of this polynomial function from its standard form. So the degree is 2 because that's the highest power on the variable in the standard form. And the leading coefficient here is the coefficient of the term with the highest power or exponent on the variable, and that's this term. So in this case, the leading coefficient is -1 because that's the coefficient of this term. Another way to visualize that is to rearrange the terms in this equation. So if we do that, we get -x squared plus 4x. So this helps us visualize that the leading coefficient is -1. So now we can analyze the third function. Now in the third function, both terms have the same variable and their exponent. So the first thing we can do here is to combine these terms so that we get the reduced form or the most rationalized form for this function. So these two terms can be combined by adding the coefficients. So 3 plus 2, which is equal to 5. So we get 5x. And now we can identify whether this function is polynomial or not. So as you can see, the variable has exponent 1 here, the invisible one, which is a whole number, and there is no other term. So this is a polynomial function. And the degree in this case is 1 because that's the highest power on the variable. And the leading coefficient here is 5, not 2 or 3. So now we can analyze part D. Now in this function, so the exponent on the variable is a negative number. So this is not a whole number because whole numbers are positive numbers. So in this case, this is not a polynomial. So since it's not a polynomial function, we don't have to identify its degree and leading coefficient. We do that only for polynomial functions. Now we can analyze the last equation. Now this is a function which is in factored form. So this is not in standard form. Here, since the exponent is 3, it can take some time to convert this factored form to standard form. So we don't want to do that. But if we are able to visualize the steps for converting this factored form to standard form, so I can just quickly show you. So basically what we'll do is we will distribute the cube by writing this x minus 1 3 times. And then we will distribute the terms. All the variable terms that we'll get will have the exponent as whole number. So this is a polynomial function. So we don't need to do this step, but we should be able to visualize it by doing the distribution in our mind. And the degree of this polynomial function will be 3, because if we distribute all the x terms in these parentheses, we'll get x cubed as the variable term with the highest power. So that's why the degree is 3. Now the leading coefficient is equal to 5, because once we do all the distribution for the terms in the parentheses, then we'll have to distribute the 5 because we want the function to be in standard form. And when we distribute the 5, the variable term with the highest power will be 5x cubed. So that's why the leading coefficient for this polynomial function is 5. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.